No radar operator in the Soviet Union ever forgot the moment it happened. The screens would light up with a blip that should not have existed. Too fast, too high, and too confident. Alarms screamed, phones rang, generals were summoned. Missiles were armed, fighters scrambled, commands shouted. And then, just as suddenly as it appeared, the blip vanished. Not destroyed, not intercepted, simply gone. The Americans never announced those flights. They never needed to. The sky itself delivered the message. Somewhere above the curvature of the Earth, higher than any conventional aircraft had a right to fly, faster than any missile the Soviets could launch, a long black aircraft streaked across forbidden airspace. Its skin shimmered with heat. Its engines inhaled the sky itself. Its pilots, sealed inside pressure suits like astronauts, looked down upon a hostile world that could do nothing to stop them. That aircraft was the SR-71 Blackbird. And its story is not merely about speed or altitude. It is a story of fear, secrecy, brilliant engineering, political brinksmanship, and a Cold War struggle where knowledge was more powerful than bombs. To understand how such a machine came to exist, one must first understand the terror that gave birth to it. In the early 1950s, the United States lived with a constant, gnawing uncertainty. The Soviet Union was no longer a wartime ally. It was an adversary with nuclear weapons, an opaque political system, and vast territory sealed behind the Iron Curtain. American intelligence agencies knew shockingly little about Soviet military capabilities. How many bombers did they have? Where were their missile sites? How advanced was their nuclear program? Guesswork was not enough. In the nuclear age, guessing wrong could end civilization. The first solution was simple in concept and dangerous in execution. Fly over the Soviet Union and take pictures. Thus was born the U-2 spy plane, an elegant glider-like aircraft that flew higher than any fighter of its time. For a while, it worked beautifully. Soviet radar could see the U-2, but their missiles could not reach it. American intelligence finally began to see what lay behind the curtain: air bases, missile fields, nuclear facilities. Presidents slept better knowing they had eyes in the sky. But technology never stands still. On May 1, 1960, a U-2 piloted by Francis Gary Powers was shot down over Sverdlovsk. Powers survived, was captured, and paraded before the world. The illusion of invulnerability shattered overnight. President Eisenhower was humiliated, diplomatic relations plummeted, and one truth became unavoidable: high altitude alone was no longer enough. If the United States was going to continue gathering intelligence without triggering war, it needed something radically different, something that could not be shot down not because it was invisible, but because it was untouchable. Speed would become the new shield. This realization set in motion one of the most secretive, ambitious engineering projects in human history. At a secluded facility in Burbank, California, hidden behind unmarked buildings and guarded by silence, Lockheed's Advanced Development Division, better known as the Skunk Works, began to imagine an aircraft unlike anything ever built. The team was led by Clarence Kelly Johnson, a man legendary for solving impossible aerospace problems with ruthless efficiency and unorthodox thinking. Johnson understood the challenge immediately. To survive over enemy territory, the aircraft would need to fly faster than missiles and higher than interception aircraft could climb. That meant sustained speeds above Mach 3 and altitudes over 80,000 feet. No existing plane could even approach those numbers, let alone survive them repeatedly. At such speeds, air itself became an enemy. Friction would heat the aircraft's skin to hundreds of degrees Fahrenheit. Conventional aluminum would melt or lose structural integrity. Fuel would boil. Lubricants would burn. Electronics would fail. Even the human body could not survive without protection. The Blackbird would require not just a new airplane, but new materials, new fuels, new engines, new manufacturing techniques, and new ways of thinking about flight. The first problem was metal. Titanium emerged as the only viable option. It was strong, lightweight, and could withstand the extreme heat generated by Mach 3 flight. There was just one problem. The United States did not have enough high-quality titanium to build the aircraft. The irony was almost absurd. The world's largest supplier of titanium was the Soviet Union, the very nation the Blackbird was being designed to spy on. Through an elaborate network of shell companies and international intermediaries, the CIA quietly purchased Soviet titanium without revealing its true destination. The Soviets knowingly sold the raw material that would later be used to spy on their own most sensitive military installations. But titanium brought its own challenges. It was notoriously difficult to machine. Traditional manufacturing tools wore out quickly. Welding techniques had to be reinvented. Even the oils used in factories could contaminate titanium and weaken it, forcing Lockheed to develop new production environments and handling procedures. Then there was the issue of expansion. At Mach 3, the Blackbird's skin would heat so much that the aircraft would physically grow in size. Engineers deliberately designed the plane with gaps in its panels when cold. On the ground, fuel leaked constantly through these seams. Blackbirds famously dripped fuel on the tarmac, appearing broken or poorly built to the untrained eye. In reality, it was by design. Once airborne and at speed, the metal expanded, sealing the gaps perfectly. Only then did the aircraft become fully fuel-tight. Pilots would often take off with partially filled tanks, refueling in midair after the plane had heated and expanded. Nothing about the Blackbird was conventional. Its engines, the Pratt & Whitney J58s, were not true turbojets in the traditional sense. At high speeds, they behaved more like ramjets. Most of the incoming air bypassed the core of the engine entirely, flowing around it and generating thrust through controlled shock waves inside the inlet cones. These cones, sharp, movable spikes at the front of each engine, were critical. A miscalculation of just inches could cause an unstart, a violent loss of airflow that would slam the aircraft sideways at supersonic speed. Pilots trained extensively for such events. They had to react instantly, adjusting controls while traveling faster than a rifle bullet. The fuel itself was exotic. Known as JP7, it had an extremely high flash point, making it difficult to ignite, an essential property given the heat surrounding it. To burn JP7, the engines used a chemical called triethylborine, which ignited on contact with air. Each engine start produced a distinctive green flash, a signature known only to those who worked with the Blackbird. Every solution created new problems. Every problem demanded a breakthrough. And all of it was wrapped in layers of secrecy so thick that even many within the U.S. military had no idea what was being built. Test flights were conducted at Groom Lake, Nevada, better known today as Area 51. Pilots who flew the early prototypes signed agreements that effectively erased the aircraft from their resumes. Crashes were covered up as conventional accidents. Families were given vague explanations. Silence was mandatory. The first Blackbird variant, the A-12, took to the skies in the early 1960s, sleek, black, and alien in appearance. Its chines, sharp edges running along the fuselage, helped reduce radar cross-section, an early and primitive form of stealth. Its black paint was infused with iron ferrites to absorb radar energy and radiate heat more efficiently. Despite all precautions, the A-12 program was deadly. Several pilots lost their lives during testing, victims of mechanical failures, unstarts, or the unforgiving nature of high-speed flight. Each loss reinforced the aircraft's danger, but also its necessity. From the A-12 emerged the SR-71, a modified version designed for the U.S. Air Force, with improved sensors, longer range, and a second crew member,
the Reconnaissance Systems Officer, or RSO. While the pilot focused on flying, the RSO managed cameras, radar, electronic intelligence systems, and navigation. By the mid-1960s, the SR-71 was ready. It would not fly low and sneak beneath radar. It would not hide behind invisibility. Instead, it would announce itself with raw speed and altitude, an airborne declaration that some things simply could not be stopped. When the Blackbird finally began operational missions, it rewrote the rules of aerial reconnaissance. Flying from bases in the United States, the United Kingdom, and later Japan, SR-71s crossed continents in hours. A mission over hostile territory could gather more intelligence in a single flight than months of satellite passes. Soviet air defenses reacted with fury and frustration. Radar tracked the aircraft, missile batteries fired.
Fighters climbed desperately, only to fall away as the Blackbird accelerated beyond reach. Over 4,000 missiles were reportedly launched at SR-71s over the course of the Cold War. None ever hit. Inside the cockpit, the experience was surreal. At cruising speed, the sky darkened to deep blue. The curvature of the Earth was visible. The engines roared with a steady, controlled violence. Warning lights flickered constantly, normal for an aircraft operating at the edge of physics. The pilots did not maneuver to evade threats. They simply went faster. And as the Blackbird flew, it gathered secrets that shaped world history, evidence that prevented miscalculations, confirmed treaty violations, and sometimes, quietly, prevented war. But the cost of this supremacy was immense, and the political risks were constant. Each flight carried the possibility of international incident, technological loss, or catastrophic failure at Mach 3. Yet mission after mission, the Blackbird returned. Not because it was invisible, but because it was untouchable. And this was only the beginning. By the time the SR-71 officially entered service, the Cold War had hardened into a permanent state of tension. There were no declarations, no marching armies across borders, but the world lived under the shadow of instant annihilation. Nuclear missiles sat in silos, bombers waited on runways, submarines prowled beneath oceans. The margin for error was terrifyingly thin. In this environment, information was survival. Every Blackbird mission began long before the aircraft ever moved. Weeks in advance, intelligence analysts studied satellite data, intercepted communications, and political developments. Targets were chosen with extreme care. Missile test ranges, bomber bases, radar installations, submarine pens, nuclear facilities hidden deep within Soviet territory. The goal was not provocation, but certainty. The United States needed to know what the Soviet Union could do, not what it claimed it could do. Flight plans were crafted to the second. At Mach 3, a deviation of even a few seconds could mean missing a target or drifting into more heavily defended airspace. Weather patterns at multiple altitudes were analyzed. Solar activity was monitored because ionospheric disturbances could interfere with navigation and sensors. The crews themselves were a rare breed. SR-71 pilots were not ordinary fighter jocks. Most came from elite backgrounds, test pilots, experienced reconnaissance aviators, men accustomed to flying experimental aircraft at the edge of the envelope. They trained endlessly in simulators and high-altitude aircraft, learning to manage emergencies that had never existed before the Blackbird. The pressure suits they wore were essentially early spacesuits. At 80,000 feet, the air was too thin to sustain life. A cockpit depressurization at Mach 3 would be fatal in seconds without protection. The suits were bulky, uncomfortable, and required hours of preparation. Even going to the bathroom was a complicated process involving tubes and valves. Before every mission, pilots breathed pure oxygen for hours to purge nitrogen from their blood, preventing decompression sickness.
Only then were they sealed into their suits, strapped into the narrow cockpit, and connected to the aircraft's life support systems. The SR-71 itself waited on the ramp like a predatory animal, long, sharp, matte black, its chines blending seamlessly into the wings. Heat waves shimmered around it even before startup. Drip fell steadily from its seams, forming puddles beneath the aircraft. To an outsider, it looked broken. To those who knew, it looked perfect. Engine start was a ritual. Ground crews ignited the engines using triethyl borine, producing brief green fireballs that lit the dawn or dusk. The J-58 settled into a low, thunderous rumble, not yet the screaming monsters they would become at altitude. Taxiing required precision. Visibility from the cockpit was limited, and the aircraft's long nose made ground handling awkward. Takeoff was always dramatic. As the Blackbird accelerated down the runway, the sound was unlike anything else in aviation, a deep metallic roar that seemed to tear at the air itself. Rotation came quickly. The aircraft lifted, gear retracted, and within minutes it was climbing steeply toward the stratosphere. But this was only the beginning. The real transformation occurred during refueling. Shortly after takeoff, the SR-71 rendezvoused with a tanker aircraft, often a modified K-135 equipped to handle JP-7 fuel. Refueling an ordinary jet was challenging enough. Refueling the Blackbird was something else entirely. The SR-71 approached at high speed, its pilot delicately balancing throttle and control inputs. The tanker crew watched nervously as the black shape slid into position. Once connected, tens of thousands of pounds of fuel flowed into the aircraft, filling tanks that would soon expand under heat. Only after refueling did the mission truly begin. The pilot pushed the throttles forward, and the aircraft began to climb again, higher, faster. As it accelerated through Mach 1, shock waves formed around the fuselage. At Mach 2, temperatures rose rapidly. By Mach 3, the skin glowed with heat invisible to the naked eye, but measurable in hundreds of degrees. Inside the cockpit, the noise changed. The engines settled into a smooth, powerful rhythm. The sky darkened. The horizon curved. The Blackbird was no longer an airplane. It was something closer to a spacecraft skimming the edge of space. As it crossed into hostile airspace, Soviet radar operators saw it immediately. There was no attempt at stealth in the conventional sense. The SR-71 was large, fast, and impossible to hide completely. Its advantage lay elsewhere. Soviet air defense doctrine relied on layered systems, early warning radars, ground-controlled interceptors, surface-to-air missile sites. Against bombers or slower reconnaissance planes, these systems were deadly. Against the Blackbird, they were helpless. Missile batteries launched salvos of SA-2 and later SA-5 missiles. Fighters scrambled, MiG-21s, MiG-25s, aircraft pushed to their limits in desperate climbs. Controllers vectored them with urgency, calculating intercept points that always slipped away. The Blackbird simply outran them. Missiles exploded harmlessly behind it, detonating where the aircraft had been moments earlier. Inside the Blackbird, the crew remained calm. The aircraft was designed to be shot at. Warning systems detected radar locks and missile launches, displaying them as lights and tones. Crews monitored these signals constantly, but the response was almost always the same: increase speed. There were no violent evasive maneuvers, no sharp turns. At Mach 3, turning too aggressively could overstress the airframe or cause an engine unstart. The Blackbird's defense was its performance envelope. As long as it stayed within it, nothing could touch it. Meanwhile, the sensors worked relentlessly. High-resolution cameras captured images of Soviet installations with astonishing clarity. Radar systems mapped terrain and structures, regardless of weather or darkness. Electronic intelligence equipment intercepted radar emissions, communications signals, and telemetry data from missile tests. In a single pass, an SR-71 could collect information that would take weeks for satellites to gather, if satellites could gather it at all. Unlike satellites, the Blackbird could be redirected mid-mission, retasked to investigate emerging developments, or flown repeatedly over the same area at different times. The value of this intelligence was incalculable. During periods of heightened tension, such as the aftermath of the Cuban Missile Crisis or during arms control negotiations, the SR-71 provided confirmation. It showed whether missile silos were active or empty, whether bombers were on alert or parked, whether treaty obligations were being honored or quietly violated. In many cases, what the Blackbird revealed was not aggression, but restraint. This knowledge prevented overreaction. It calmed nerves in Washington. It allowed policymakers to make decisions based on reality rather than fear. But the aircraft was not invincible. Every mission carried risks beyond enemy action. At Mach 3, even small mechanical failures could escalate into catastrophe. A sensor glitch could distract a crew at the wrong moment. A minor fuel imbalance could affect stability. An engine unstart could slam the aircraft sideways with brutal force. Pilots trained endlessly for these scenarios, but training could not eliminate danger. On one mission, a Blackbird experienced an unstart over hostile territory. The aircraft yawed violently, throwing the pilot against his restraints. Instruments went wild. For a moment, the aircraft teetered on the edge of control. The pilot reacted instantly, throttling back, stabilizing the aircraft, restarting the engine. The entire event
Lasted seconds, but those seconds felt like eternity. Had control been lost, ejection was an option, but a terrifying one. Ejecting at Mach 3 was unlike anything else in aviation. The forces involved were extreme. The risk of injury or death was high, even if the ejection system functioned perfectly. And descending by parachute into enemy territory was a fate few wanted to contemplate. Yet despite these dangers, the missions continued. Year after year, the Blackbird flew. It flew over the Soviet Union's periphery, over China, over North Korea, over Vietnam. During the Vietnam War, SR-71s provided critical intelligence on troop movements, missile sites, and air defenses. They detected launches of surface-to-air missiles within seconds, allowing U.S. aircraft to be warned in real time. The Blackbird was not armed, it dropped no bombs, yet its impact on warfare was profound. It changed how wars were planned, how crises were managed, how intelligence was gathered. Still, secrecy remained paramount. Even within the U.S. Air Force, knowledge of the SR-71 was tightly compartmentalized. Many pilots flying combat missions in Southeast Asia had no idea that a Blackbird was passing overhead, silently watching the battlefield from the edge of space. When the aircraft was publicly acknowledged, the details were minimal. Speeds were understated, altitudes vague, capabilities obscured. The true extent of its performance remained classified for decades. Soviet intelligence, meanwhile, struggled to understand what they were facing. They knew the aircraft was fast, faster than anything they had. They developed faster interceptors like the MiG-25 Foxbat specifically to counter it. They built new missile systems, improved radars, refined tactics. None of it worked. Each failure was a quiet humiliation, a reminder that American aerospace technology had leaped ahead in ways they could not match quickly enough. Yet even as the Blackbird dominated the skies, forces were gathering that would eventually challenge its existence. Satellites grew more capable, political priorities shifted, budgets tightened. The aircraft was expensive to operate, demanding specialized crews, tankers, maintenance, and infrastructure. Some questioned whether it was still necessary. Others argued it was irreplaceable. Within this debate lay the future of the Blackbird,
and the end of an era when men routinely flew faster than bullets over the most dangerous airspace on Earth. But before that end came, the SR-71 would face its greatest tests, fly its most daring missions, and prove again and again why it had earned its legend. And the world would never fully know just how close it had come to disaster or salvation. By the late 1960s, the SR-71 Blackbird had become something more than a reconnaissance aircraft. It was a strategic instrument, a psychological weapon, and a silent participant in the most dangerous standoffs of the Cold War. Its presence in the sky altered calculations on both sides of the Iron Curtain, even when no one publicly acknowledged it. Inside the Soviet Union, the Blackbird inspired a unique blend of fear, frustration, and obsession. Soviet radar networks were among the most extensive on Earth. Stretching across thousands of miles, they formed an electronic wall designed to detect and track any intrusion into Soviet airspace. Every SR-71 flight lit up that wall like a lightning strike. Operators knew the moment the aircraft approached. They watched it cross their screens with impossible speed, violating airspace they were sworn to defend. Command centers erupted into activity. Procedures were followed with rigid discipline. Missile batteries were alerted. Fighter regiments were scrambled. Political authorities were notified. And then, inevitably, the outcome repeated itself. The aircraft could not be intercepted. Each failure triggered internal investigations. Engineers were summoned. Generals demanded answers. Reports circulated analyzing trajectories, speeds, altitudes, and engagement envelopes. The conclusion was always the same. The SR-71 operated beyond the effective reach of existing systems. This was not merely a military problem, it was a political one. The Soviet Union had built its legitimacy in part on the image of technological parity or superiority with the United States. The Blackbird undermined that image every time it flew. It demonstrated, silently and irrefutably, that there were areas where American technology had pulled far ahead. In response, the Soviets invested heavily in countermeasures. The MiG-25 Foxbat was one such response. Designed as a high-speed interceptor, it was capable of extraordinary performance on paper. In controlled conditions, it could approach Mach 3 and climb to extreme altitudes. Western intelligence initially feared it might match or even exceed the Blackbird's capabilities. But reality was less impressive. The MiG-25 was fast, but not agile. Its engines could not sustain maximum speed without damage. Its radar and missiles struggled to lock onto a target moving as fast and as high as the SR-71. Pilots could attempt intercepts, but the geometry rarely worked. By the time a Foxbat reached altitude, the Blackbird was already gone. Missile systems fared no better. Surface-to-air missiles relied on predicting where a target would be, not where it was. Against slower aircraft, this worked. Against the SR-71, prediction became nearly impossible. Even slight variations in speed or altitude rendered missile solutions useless. There were moments of false hope. On several occasions, missile proximity detonations occurred close enough for Soviet commanders to believe the Blackbird had been damaged or destroyed. Celebratory reports were drafted, claims were prepared. But the aircraft always returned. Back in the United States, analysts reviewed mission data with intense scrutiny. Every radar signal, every missile launch, every attempted intercept was logged and studied. The SR-71 was not just gathering intelligence, it was collecting data on enemy defenses themselves. In this way, each flight made future flights safer. Yet danger remained ever present. One of the most harrowing aspects of Blackbird operations was navigation. At Mach 3, traditional navigation methods were insufficient. The aircraft traveled so fast that even minor errors could have major consequences. Advanced inertial navigation systems guided the Blackbird across continents with astonishing precision, but they were not infallible. Solar flares could disrupt signals, gyroscopes could drift, a single faulty reading could send the aircraft off course. In one incident, an SR-71 strayed dangerously close to the border of a neutral country during a mission near the Soviet Far East. The deviation was small in absolute terms, mere miles, but politically enormous. Had the aircraft crossed into the wrong airspace, it could have triggered an international crisis or worse. The crew corrected course just in time, unaware until later how close they had come to international disaster. The physical toll on pilots was immense. Flying the Blackbird was not physically strenuous in the conventional sense. There were no high-G dogfights or violent maneuvers. Instead, the strain came from duration, isolation, and constant vigilance. Missions often lasted 8 to 10 hours, sometimes longer. The cockpit was cramped, movement was limited by the pressure suit. Meals were consumed through tubes, consisting of pureed food designed to be eaten without removing the helmet. Hydration was critical, yet inconvenient. Waste management systems were primitive compared to modern standards. Discomfort was constant. And then there was the heat. Despite advanced cooling systems, cockpit temperatures could rise significantly during sustained high-speed flight. Instruments became warm to the touch. The pilot could feel the aircraft radiating heat like a living thing under strain. Outside, the aircraft's skin expanded dramatically. Cameras and sensors had to be designed to function despite this expansion. Windows were made of special fused quartz, capable of withstanding both heat and pressure. Every detail mattered. Behind the scenes, ground crews worked tirelessly to keep the Blackbird flying. Maintenance was intensive and unforgiving. Each flight required hours of inspection, repair, and recalibration. Specialized tools and facilities were necessary. The aircraft's stealth coatings had to be maintained carefully. Engine components were monitored for signs of stress. Despite these demands, the SR-71 achieved an operational reliability that surprised even its designers. As the 1970s progressed, the Blackbird's role expanded. It was used not only against the Soviet Union, but also in monitoring flashpoints around the world. In the Middle East, SR-71s flew missions during periods of heightened tension, providing intelligence on troop movements and military readiness. In Asia, they watched developments on the Korean peninsula, where the threat of sudden conflict loomed constantly. In one particularly tense period, the Blackbird was tasked with monitoring a series of missile tests. Flying along the edge of hostile airspace, it captured telemetry data that revealed the true capabilities of the missiles being tested. This information contradicted public claims and altered strategic assessments in Washington. The aircraft's value was never
more apparent than during moments of crisis. Yet even as it proved indispensable, political winds shifted. The Vietnam War drained resources and public support. Domestic priorities competed with defense spending. Critics questioned the cost of maintaining a small fleet of highly specialized aircraft. At the same time, satellite reconnaissance advanced rapidly. Orbital platforms offered persistent coverage without risking pilots. They could not be shot down in the same way aircraft could. They were politically less provocative. Some argued that satellites made the Blackbird obsolete. Those who had flown it disagreed. Satellites followed predictable orbits. Adversaries knew when they would pass overhead and could conceal activities accordingly. The SR-71, by contrast, could appear without warning, fly at will, and be redirected in real time. It provided not just images, but context. Still, the debate intensified. Within the Pentagon, the Blackbird became a symbol of an older philosophy, one that valued daring, speed, and human skill. To some, it represented unnecessary risk. To others, it represented unmatched capability. Amid this uncertainty, the SR-71 continued to fly. Its crews focused not on politics, but on their missions. Each takeoff could be the last. Each landing was a small victory. And as tensions flared and subsided across the globe,
the Blackbird remained a constant presence, silent, unseen by the public, but always watching. The sky had become a battlefield, and the SR-71 ruled it. But unseen by most, cracks were forming, not in the aircraft itself, but in the world that had created it. And soon, events would unfold that would test the Blackbird's limits more severely than ever before. By the early 1970s, the SR-71 Blackbird had become both indispensable and dangerously routine. Missions that would have been considered unthinkable only a decade earlier were now executed with clockwork precision. Crews planned, launched, refueled, penetrated hostile airspace, gathered intelligence, and returned, all without public acknowledgement. The aircraft's survival record bred confidence. But confidence in the Cold War was always shadowed by risk. Behind closed doors, U.S. policymakers wrestled with an uncomfortable truth. Every Blackbird flight carried the potential to ignite a crisis that no one could control. While the SR-71 was unarmed, its presence was unmistakably provocative. To Soviet commanders, it represented a violation of sovereignty, an insult to their defenses, and a reminder of American technological dominance. The question was never whether the aircraft could survive a mission. The question was what might happen if something went wrong. One of the most persistent myths surrounding the SR-71 was that it routinely flew deep into Soviet airspace with impunity. The reality was more nuanced. While some early reconnaissance flights probed the edges of Soviet territory, later missions were carefully constrained. The aircraft often flew along borders or over international waters, using its sensors to peer deep into denied regions without physically crossing the line. Even so, the distinction meant little to those tracking it on radar. Soviet air defense commanders reacted aggressively to every appearance. They had standing orders to engage if possible. Missile crews trained relentlessly, refining timing and coordination in the hope of one day achieving a successful intercept. Fighter pilots pushed their aircraft beyond safe limits in desperate climbs. Inside the Kremlin, the Blackbird was discussed at the highest levels. Some hardliners argued that allowing such flights to continue unchallenged was a sign of weakness. They advocated more aggressive responses, even at the risk of escalation. Others urged caution, recognizing that shooting down an American reconnaissance aircraft, especially one carrying highly sensitive technology, could provoke a dangerous retaliation. Memories of the U-2 incident still lingered. In Washington, similar debates unfolded. The intelligence value of the SR-71 was undeniable. So was the political cost if a mission ended in disaster. Presidents and advisors weighed each operation carefully, balancing the need for information against the risk of confrontation. During moments of heightened tension, Blackbird flights were sometimes paused, not because the aircraft was vulnerable, but because the world itself was. One such moment came during a period of escalating mistrust in Europe. Intelligence suggested unusual activity at several Soviet air bases. Satellite imagery was inconclusive. Analysts suspected a large-scale exercise or something more ominous. An SR-71 mission was authorized. As the aircraft approached its target area, Soviet defenses reacted with unusual intensity. Radar locks were continuous. Missile launches were detected in rapid succession. The Blackbird's warning systems filled with alerts, painting a picture of unprecedented hostility. Inside the cockpit, the crew followed protocol. Speed increased slightly. Altitude was adjusted. Sensors continued recording. From the ground, Soviet commanders believed they were witnessing a deliberate provocation. Communications crackled with urgency. Reports were sent upward, warning of what appeared to be a major intelligence intrusion. For a brief, terrifying window, Both sides misinterpreted the other's intentions. Had a missile come closer, had the Blackbird suffered even minor damage, the consequences could have been catastrophic. A downed SR-71 would not have been a simple incident. It would have been a strategic crisis involving captured technology, potential loss of life, and intense pressure for retaliation. The aircraft completed its mission and exited the area without incident. Later analysis revealed that the Soviet activity had indeed been a large-scale exercise, not preparations for war. The intelligence gathered by the Blackbird helped defuse the situation, reassuring U.S. leaders that no immediate threat existed. The irony was stark. An aircraft that risked triggering war had, in this case, helped prevent one. Not all dangers came from the enemy. The SR-71's extreme operating environment meant that even minor technical anomalies demanded immediate attention. Crews were trained to interpret a constant stream of warnings, distinguishing between normal quirks and genuine emergencies. Fuel leaks were common. Electrical fluctuations occurred regularly. Sensors sometimes failed temporarily under intense heat. The challenge was knowing to abort. On one mission, a fuel imbalance developed at high speed. At Mach 3, fuel distribution was critical to maintaining stability. The crew monitored the situation closely, adjusting transfer rates and engine settings. For minutes that felt like hours, the aircraft teetered on the edge of safe parameters. Abort procedures were initiated. Turning back was not simple. At high speed and altitude, the SR-71's turning radius was enormous. Descent had to be gradual to avoid thermal shock. Fuel calculations had to be revised instantly. The crew managed the situation flawlessly, returning safely. Maintenance crews later discovered a malfunctioning valve that could have caused a catastrophic failure if left unchecked. Such incidents reinforced a sobering truth. The SR-71's greatest enemy was not Soviet missiles, but physics itself. Despite these challenges, the aircraft's reputation grew. Among those who flew it, the SR-71 inspired a unique sense of pride. Pilots spoke of the aircraft with reverence, describing it as demanding but honest. If treated correctly, it rewarded discipline. If mishandled, it punished mistakes mercilessly. There was little room for ego. The Blackbird tolerated no shortcuts. As the 1970s advanced, détente reshaped the geopolitical landscape. Arms control treaties were signed. Tensions eased, at least on the surface. Some questioned whether the SR-71 was still necessary in an era of improved relations. Yet behind diplomatic smiles, suspicion remained. Treaties required verification. Promises needed confirmation. The Blackbird provided both. During negotiations, SR-71 missions quietly verified compliance. Missile silos were counted. Bomber deployments were monitored. New construction detected early. In this way, the aircraft became an enforcer of peace, not through force, but through knowledge. Still, budgets tightened. The SR-71 was expensive. Each flight cost hundreds of thousands of dollars. Specialized
Fuel, tankers, maintenance crews, and infrastructure added up quickly. Decision-makers scrutinized every line item. Advocates argued that the cost of ignorance was far higher. Critics countered that satellites could do the job more cheaply and without risking pilots. The debate intensified when several high-profile accidents occurred, not due to enemy action, but mechanical failure. Each crash prompted investigations, grounding periods, and renewed questions about safety and necessity. Families mourned quietly. Details remained classified. The public heard little. Inside the program, resolve hardened. Those who worked on the Blackbird believed deeply in its mission. They knew what the aircraft could do and what might happen without it.
Yet the world was changing. Computers grew more powerful, satellites more capable, political priorities shifted toward diplomacy and arms reduction. Unnoticed by the public, the SR-71 program began to feel the pressure of time. The aircraft itself remained unmatched, but the era that had created it was slowly slipping away. And as new threats emerged and old certainties faded, the Blackbird would soon face challenges not from the sky, but from decisions made far below it. By the mid-1970s, the SR-71 Blackbird faced an enemy it could not outrun. It was not a missile. It was not a fighter jet. It wasn't even a foreign power. It was bureaucracy. Inside the Pentagon, a quiet but relentless battle unfolded. Defense budgets were under pressure from multiple directions. The Vietnam War had consumed enormous resources. Domestic priorities demanded attention. New weapons systems competed for funding. In this environment, the SR-71's unique and costly nature made it a tempting target. The aircraft was undeniably expensive. Each mission required meticulous planning, specialized crews, dedicated tankers, and maintenance teams that worked around the clock. The fuel alone, JP-7, was produced in limited quantities and handled with extreme care. Spare parts were custom-made. Training pipelines were narrow and slow. Critics asked uncomfortable questions. Why maintain a small fleet of exotic aircraft when satellites could provide global coverage? Why risk pilots when machines in orbit faced no direct threat? Why invest in a platform designed for a previous era of confrontation? To those who had never worked with the SR-71, these questions seemed reasonable. To those who had, they missed the point entirely. Supporters of the Blackbird argued that satellites and aircraft served fundamentally different purposes. Satellites followed predictable orbits. Adversaries knew when they were coming and adjusted accordingly. The Blackbird could appear unexpectedly, observe dynamically, and adapt to unfolding events. It provided not just images, but insight. Inside intelligence agencies, analysts quietly sided with the aircraft. They had seen the quality of its data. They trusted its sensors. They valued its flexibility. When a crisis erupted, they wanted the Blackbird in the air. But the influence was uneven. In 1976, serious proposals emerged to curtail or even terminate SR-71 operations. Advocates were forced into a defensive posture, justifying every flight, every dollar, every maintenance hour. They compiled reports highlighting the aircraft's contributions, classified briefings showing how Blackbird intelligence had shaped policy decisions, prevented miscalculations, and confirmed treaty compliance. Many of these successes could not be discussed publicly. This secrecy weakened the program's defenders. They could not point to headlines or medals. They could not reveal how often the aircraft had been the difference between clarity and confusion. Meanwhile, technology marched on. Advances in satellite imaging improved resolution and responsiveness. Electronic intelligence platforms proliferated. Unmanned systems began to emerge, hinting at a future where human pilots might no longer be necessary for dangerous reconnaissance missions. The SR-71, once the embodiment of the future, now risked being seen as a relic of the past. Within the Blackbird community, morale wavered but did not break. Pilots continued to train, maintenance crews continued to innovate, engineers refined procedures to reduce costs and improve reliability. The aircraft itself remained unmatched in performance. Some pilots later recalled the strange duality of that period, flying the most advanced aircraft in the world while knowing that its existence was constantly under threat from accountants and committees. Yet the Blackbird refused to fade quietly. Throughout the late 1970s, it continued to prove its worth. In regions where satellites were hindered by weather or political constraints, the SR-71 delivered. During sudden crises, when rapid intelligence was essential, it was often the only platform capable of responding in time. One such moment occurred during a period of instability in Asia. Intelligence suggested a rapid buildup of forces near a sensitive border. Satellite coverage was limited, time was critical, and SR-71 was launched. Within hours, it provided detailed imagery and electronic data that clarified the situation. The buildup was defensive, not offensive. Tensions eased. Diplomatic channels were engaged. Again, the Blackbird had done its job. But the victories were increasingly quiet and increasingly fragile. In 1979, the strategic landscape shifted dramatically. The Soviet invasion of Afghanistan shattered assumptions about détente. Cold War tensions surged anew. Suddenly, intelligence demands spiked. The need for rapid, reliable reconnaissance returned with urgency. For the SR-71, this was both an opportunity and a reprieve. Flights increased. Missions were approved that might have been denied just months earlier. The aircraft once again found itself at the center of strategic planning. Yet the respite was temporary. As the 1980s approached, a new generation of defense thinkers rose to prominence. They favored stealth, unmanned systems, and networked intelligence. They admired the Blackbird, but they did not see it as the future. Ironically, many of the concepts they championed had roots in the SR-71 program itself. The aircraft's reduced radar signature, heat management techniques, and systems integration influenced later designs, including stealth aircraft that would redefine aerial warfare. The Blackbird was becoming a victim of its own legacy. Even so, attempts to retire it met resistance. Each proposal was countered with operational evidence. Each argument for cancellation was met with reminders of unique capabilities. The program survived, barely. Behind the scenes, compromises were made. Fleets were reduced. Flight hours were scrutinized. Training pipelines were tightened. The Blackbird community adapted, determined to keep the aircraft flying as long as possible. For the pilots, the knowledge that each mission might be among the last added a new weight. They flew with the same precision, but with a heightened sense of finality. Every takeoff mattered. Every landing felt more significant. They were custodians of something irreplaceable. And as the world entered a new decade marked by renewed rivalry, technological revolution, and political upheaval, the Blackbird prepared to face its final and most complex chapter. A chapter that would test not just the aircraft's performance, but its place in history. By the early 1980s, the SR-71 Blackbird had reached the peak of its operational maturity. The aircraft, once experimental and temperamental, had become a finely tuned instrument of national power. Its crews were among the most experienced aviators in the world. Its maintenance teams knew every quirk, every weakness, every strength. And yet, despite this refinement, every mission still demanded perfection. There was no margin for complacency. The Cold War had entered a new phase, one marked by renewed hostility, ideological rigidity, and a dangerous mix of mistrust and technological escalation. The Soviet Union, under aging leadership, faced internal stagnation but remained militarily formidable. The United States, under a new administration, pursued a more assertive posture, emphasizing strength and deterrence. In this atmosphere, intelligence once again became urgent. The Blackbird was called upon more frequently. Missions increased in tempo. Flight schedules tightened. Crews rotated through a relentless cycle of preparation, execution, and recovery. Unlike earlier years when the SR-71's very existence had been shrouded in near-total secrecy, the aircraft was now quietly acknowledged, though its true capabilities remained classified. To the public, it was an impressive but distant symbol. To those who flew it, it was a living system that demanded constant respect. A typical mission began long before dawn. Pilots and Reconnaissance officers arrived hours early, briefing in secure rooms filled with maps, charts, and classified overlays. Intelligence officers explained the geopolitical context of the flight, what had changed, what was suspected, what needed confirmation. Sensor specialists reviewed equipment settings. Meteorologists provided detailed forecasts for multiple altitudes and regions. Every detail mattered.
The crew memorized timelines, checkpoints, fuel states, and contingencies. At Mach 3, there would be no time to debate decisions.
Had to be automatic. As they suited up, the psychological transition began. The pressure suit sealed the crew away from the outside world, isolating them physically and mentally. Once inside, there was no casual movement, no stretching, no adjustment without effort. Every action became deliberate. Taxiing to the runway, the Blackbird felt massive yet strangely delicate. The pilot's view was limited, requiring trust in ground crew signals. The engines, once started, produced a sound that vibrated through bone and muscle. Takeoff was still exhilarating, even for veterans. Within minutes, the aircraft climbed steeply, leaving behind the familiar sky. After refueling, the true ascent began. As speed increased, the aircraft's behavior changed subtly. Controls stiffened. The sensation of motion smoothed out. Turbulence faded. The world below flattened and curved at the same time. Pilots later described the moment they reached cruise as crossing an invisible threshold. Below them lay weather, borders, politics, and conflict. Above them, near space, there was only physics. At operational altitude, the SR-71 flew above more than 95% of the atmosphere. The sky turned a deep indigo. Stars were sometimes visible even in daylight. The sun appeared brighter, harsher, unfiltered by dense air. Time took on a different meaning. At Mach 3, the aircraft covered a mile every second. Entire countries passed beneath the fuselage in minutes. Checkpoints came and went rapidly. Navigation systems ticked relentlessly, updating position with astonishing accuracy. When the Blackbird approached sensitive regions, Soviet reactions remained consistent, fast, furious, and ultimately futile. Warning systems lit up with radar emissions. Missiles were detected powering up. Crews acknowledged each alert, noting parameters, but rarely changing course. The aircraft was operating exactly as designed. Inside Soviet command centers, the situation looked very different. The Blackbird's appearance triggered alarm protocols that had been refined over decades. Operators tracked its path obsessively, calculating speed, altitude, and heading. Fighter units scrambled, even when experience suggested the effort was futile. Missile batteries launched, sometimes more to demonstrate resolve than in genuine expectation of success. Each failed intercept reinforced a painful reality. The SR-71 could not be stopped. This reality weighed heavily on Soviet engineers and strategists. Enormous resources had been invested in air defense systems meant to protect the homeland. The Blackbird exposed their limitations repeatedly and publicly, at least within classified circles. The psychological effect was significant. Yet even as the Blackbird dominated the skies, its crews were acutely aware that dominance did not equal invulnerability. The aircraft's greatest threats were subtle and internal. One of the most feared events was an asymmetric engine unstart. At high speed, if one engine lost airflow while the other continued producing thrust, the aircraft could yaw violently. The force was sudden and brutal, capable of injuring crew members and stressing the airframe. Pilots trained extensively for this scenario, memorizing precise recovery steps. Even so, experiencing it in reality was something else entirely. During one mission in this period, an unstart occurred without warning. The aircraft snapped sideways, slamming the pilot against his harness. Warning lights flashed, instruments blurred. For a fraction of a second, control teetered on the edge. The pilot reacted instantly, reducing throttle, correcting yaw, and initiating restart procedures. The RSO monitored systems, calling out parameters in a steady voice. Within seconds, the aircraft stabilized. Later analysis showed that a minor sensor anomaly had triggered the event. The outcome could have been far worse. Moments like these reinforced a sobering truth. At Mach 3, survival depended on training, discipline, and teamwork. The relationship between pilot and RSO was critical. Communication had to be precise and calm. There was no room for panic or ambiguity. Each crew member trusted the other completely. This trust extended beyond the cockpit. Ground crews were an integral part of every mission. Their work was often invisible, but its importance could not be overstated. They inspected the aircraft meticulously after each flight, searching for signs of stress, fatigue, or damage. They adjusted systems, repaired components, and prepared the Blackbird for its next journey. Maintenance was not routine, it was investigative. Every flight taught lessons. Every anomaly prompted analysis. Over time, these lessons improved reliability and safety, but they also revealed the aircraft's limits. Despite the pressures, many pilots later described their time flying the SR-71 as the pinnacle of their careers. There was a sense of purpose that transcended personal ambition. They knew they were part of something rare and fleeting, a convergence of technology, politics, and human skill that might never be repeated. They also knew that public recognition would be minimal. Most missions remained classified. Many accomplishments would never be acknowledged openly. The satisfaction came from quiet knowledge, shared only among those who understood. As the decade progressed, the Blackbird continued to serve as a silent sentinel in multiple theaters. In Europe, it monitored Warsaw Pact activities, tracking deployments and exercises. In Asia, it kept watch over volatile regions where sudden conflict remained a constant risk. In the Middle East, it provided strategic awareness during periods of instability. Each region presented unique challenges, different weather patterns, terrain, and political sensitivities. The Blackbird adapted to all of them. Yet even as its operational tempo remained high, the program's future grew increasingly uncertain. Budget pressures returned with renewed force. Defense priorities shifted towards emerging technologies, stealth aircraft, cruise missiles, and space-based systems. The SR-71, with its small fleet and specialized requirements, struggled to compete for resources. Advocates within the Air Force fought to preserve it, emphasizing its unmatched speed, altitude, and flexibility. Critics countered that it was too expensive, too specialized, and too tied to a previous era. The debate reached new intensity as proposals emerged to retire the aircraft permanently. For those within the program, the prospect was deeply unsettling. They knew that once the Blackbird was gone, its capabilities could not be easily replaced. The infrastructure, expertise, and experience would disperse. The aircraft itself would become a museum piece. Some pilots wondered if they were witnessing the final chapter of a remarkable story. Still, the missions continued. Each flight was treated as essential. Each sortie carried the weight of possibility that it might be the last of its kind. The Blackbird, indifferent to politics and budgets, continued to do what it had always done: fly higher, faster, and farther than anything else on Earth. But the world below was changing rapidly, and soon events beyond the cockpit would force decisions that no amount of speed could outrun. By the mid-1980s, the SR-71 Blackbird had become a legend among those who worked with it, yet the aircraft's existence was precarious. The Cold War was entering a phase of renewed tension, and while the Blackbird had survived decades of budget cuts, bureaucracy, and political debates, its greatest threats now came from within the system that had created it.
Accidents had begun to accumulate, not at the hands of the enemy, but as inevitable consequences of extreme engineering and operational demands. One particularly harrowing event involved a Blackbird returning from a reconnaissance mission over hostile territory in Southeast Asia. The aircraft had developed a subtle fuel leak, imperceptible at Mach 2.5, but critical when speeds climbed towards Mach 3. The pilot, relying on experience, adjusted throttles incrementally, while the RSO tracked fuel flow and engine parameters. Seconds later, a minor unstart in one engine occurred. The aircraft yawed violently, throwing the pilot against his harness.
Recovery was textbook, but the incident served as a stark reminder. The SR-71 demanded not only perfection from its pilots, but also absolute diligence from ground crews. Maintenance errors or overlooked mechanical issues could instantly become life-threatening situations. Every mission was a ballet of physics, human skill, and finely tuned machinery. Any misstep had consequences. In addition to operational hazards, the Blackbird faced repeated program cancellation threats. Defense budgets were under scrutiny, and critics argued that satellites and emerging reconnaissance technologies could render the aircraft obsolete. Congress questioned whether a small fleet of exotic, costly aircraft justified their expenses. Arguments circulated: $30,000 per flight hour, specialized JP-7 fuel, dedicated KC-135 tankers, constant maintenance, and a cadre of highly trained support personnel. Program advocates countered with operational evidence. One declassified mission report detailed an SR-71 flight over the European theater during a Warsaw Pact exercise. Satellites had been limited by cloud cover and orbit schedules, yet the Blackbird penetrated the periphery, observed troop movements, and provided data that altered NATO's strategic decisions. The intelligence was critical and immediate, something no satellite could match in real time. Pilot testimonies became instrumental in defending the program. Veteran crews spoke to congressional committees, explaining the aircraft's capabilities, its unmatched speed, and its ability to gather real-time intelligence in areas where political sensitivities prevented satellite overpasses. These testimonies highlighted a crucial truth: the SR-71 was not a luxury, it was a strategic instrument. However, accidents and near misses continued to weigh heavily on program defenders. In one incident, a Blackbird suffered a catastrophic tire failure during landing at Beale Air Force Base. Though the engines were throttled down and the crew executed emergency procedures, the aircraft skidded perilously close to the edge of the runway. Extensive ground repairs were required afterward, and the maintenance team worked around the clock to restore the aircraft to flying condition. Such events reminded everyone involved that unlike unmanned systems, human lives were intrinsically linked to every flight. Despite these dangers, the Blackbird repeatedly proved its worth in high-stakes intelligence gathering. In 1983, during heightened tensions over the Soviet Union's missile deployments in Eastern Europe, SR-71 missions were flown to observe missile silos, military convoys, and radar installations. Crews gathered detailed imagery, providing verification that strategic missiles were in operational readiness. The intelligence was enabled policymakers in Washington to make informed decisions without resorting to escalation or military action. Interestingly, some missions revealed anomalies that were only understood decades later. Several flights over the Arctic and Siberian regions recorded unusual radar emissions and unexplained telemetry signals. At the time, analysts debated the nature of these signals. Were they new weapons systems, testing anomalies, or natural atmospheric phenomena? The Blackbird sensors captured data that allowed subsequent generations of engineers and historians to better understand the Soviet Union's defensive experimentation.
The threat of program cancellation never fully disappeared. In 1985, the Pentagon proposed grounding portions of the fleet to save costs. Advocates argued that grounding would erode pilot proficiency and degrade infrastructure, making full reactivation nearly impossible if strategic requirements suddenly demanded it. After tense debates, a compromise allowed limited flights to continue, but with stricter oversight and increased documentation requirements. Pilots described this era as flying under the shadow. They understood that each mission could be one of the last for their aircraft. Yet, despite administrative pressures, operational tempo remained high. The Blackbird continued to demonstrate capabilities unmatched by any other platform. Its speed, altitude, and real-time adaptability were essential during crises, and the U.S. intelligence community consistently argued that no substitute existed. Mechanical reliability had improved significantly, but the aircraft was still unforgiving. Engine unstarts, hydraulic failures, and pressurization anomalies continued to occur. The aircraft's skin expanded dramatically at high speeds, requiring careful management of aerodynamic stresses. Sensors and cameras were sensitive to thermal expansion, and even minor discrepancies could compromise intelligence collection. Crew cohesion became a defining factor. Every pilot and RSO knew that survival depended on trust, communication, and precision. The intense training paid dividends during near disasters, where split-second decisions determined the outcome. Many pilots later described their experiences as the ultimate test of human skill and resilience. Beyond operational challenges, the Blackbird also became a symbol of technological aspiration. Aerospace engineers continued to innovate, drawing lessons from its design. Heat management techniques, specialized fuels, radar reduction methods, and material science advancements pioneered during the SR-71 program directly influenced subsequent generations of aircraft, including stealth designs and high-speed reconnaissance drones. By the late 1980s, the Blackbird had become more than a reconnaissance tool. It was an icon. It represented the zenith of Cold War aerospace engineering, the collaboration of countless pilots, engineers, and ground crews, and the manifestation of national resolve. Yet the program remained in jeopardy, caught between fiscal reality and strategic necessity. Despite its legendary status, the aircraft's ultimate future depended on decisions far beyond the cockpit. Political pressures, budget constraints, and emerging technologies would soon determine whether the SR-71 could continue to operate, or whether it would be consigned to history. In this period, the Blackbird's flights became increasingly symbolic, proof of what human ingenuity and courage could achieve, flying faster than any missile, higher than any interceptor, and gathering intelligence that shaped the balance of global power. Even as the aircraft continued to perform flawlessly, those who operated it knew that every mission could be one of the last, every landing could be a final victory, and every flight was a reminder of the fragile line between technological mastery and mortality. By 1986, the SR-71 Blackbird had firmly cemented its status as the most advanced reconnaissance aircraft ever flown. Yet paradoxically, its operational future was increasingly uncertain. Emerging technologies such as improved satellite reconnaissance, unmanned aerial vehicles, and stealth aircraft were gaining traction. Meanwhile, budget pressures and shifting defense priorities created an environment where even the Blackbird, with its unmatched capabilities, was under scrutiny. Despite these challenges, the Blackbird continued to fly at Mach 3+ speeds, routinely covering thousands of miles in a single sortie. Pilots and RSOs often described a surreal sense of detachment as they observed the curvature of the Earth below, aware that few humans could witness the same perspective. The aircraft had become both a physical and psychological instrument, projecting U.S. technological superiority while gathering critical intelligence in denied areas. During this period, the SR-71 was tasked with several high-stakes missions that underscored its value. One notable operation involved monitoring Soviet radar and missile deployments in the Arctic Circle. The extreme cold, combined with magnetic anomalies and unpredictable weather, created operational challenges that few aircraft could withstand. The Blackbird's titanium structure and high-speed capabilities allowed it to operate where others could not. Mission data revealed previously unknown radar frequencies, signal patterns, and missile readiness information. This intelligence was invaluable in refining U.S. electronic warfare systems and countermeasure strategies. Simultaneously, the SR-71 program faced intensified internal pressure. Congress debated whether to fund continued operations, citing the high costs associated with maintenance, fuel, and personnel. Advocates responded with detailed mission reports, highlighting instances where the Blackbird had provided critical intelligence unavailable from satellites or other platforms. These reports, though classified, were often the deciding factor in temporarily preserving flight operations. Pilots described a unique duality during this era. They operated one of the fastest and most capable aircraft in history, yet each mission carried the weight of potential program termination. Many felt they were not just flying reconnaissance missions, but also flying for the survival of their own program. This awareness heightened the intensity of operations and the psychological demands placed on crews. Operational hazards remained significant. Engine unstarts, hydraulic system anomalies, and sensor malfunctions occurred periodically. One high-profile incident involved a fuel leak during a mission over the Middle East. The crew detected the anomaly via the aircraft's warning systems, carefully monitored fuel consumption, and executed a return trajectory that required precise adjustments to throttle and altitude. Upon landing, maintenance crews confirmed a minor but potentially catastrophic valve failure. Such events
Reinforced the understanding that while the SR-71 was incredibly reliable, it was not invincible. In addition to technical challenges, geopolitical considerations also influenced mission planning. Each sortie required coordination with allies, careful navigation of international airspace, and constant awareness of the political consequences of intrusion, even inadvertent. A misstep could provoke diplomatic crises or worse, potentially triggering retaliatory military action. As such, mission planning involved multiple layers of oversight, including the Pentagon, intelligence agencies, and allied command structures. During this period, the SR-71 continued to refine electronic intelligence (ELINT) capabilities. The aircraft's sophisticated sensor suites could detect, analyze, and record radar emissions across multiple frequencies, providing insight into adversary capabilities that could not be replicated by satellites alone. In several cases, Blackbird missions revealed previously unknown anti-aircraft systems, prompting the U.S. to adjust tactical doctrines and aircraft countermeasures. Pilots and RSOs often reflected on the unique demands of long-duration, high-speed flight. With limited opportunities for sleep, constrained movement inside the cockpit, and the constant need to monitor dozens of parameters simultaneously, operating the SR-71 required a combination of technical skill, situational awareness, and psychological resilience. Many describe their experiences as the most intense and rewarding of their careers, emphasizing that the aircraft demanded total commitment. Despite these challenges, the aircraft's strategic value remained unquestionable. During heightened tensions in Eastern Europe, the Blackbird executed a series of missions that provided real-time verification of troop movements, radar installations, and missile deployment. These missions enabled U.S. policymakers to make informed decisions without escalating conflict. In several cases, intelligence collected by the Blackbird directly influenced diplomatic negotiations, arms control discussions, and military contingency planning. Budgetary concerns, however, continued to cast a shadow. The cost of JP-7 fuel, specialized maintenance crews, and dedicated KC-135 tankers was substantial. As stealth technology matured and reconnaissance satellites offered alternative intelligence collection methods, some argued that the SR-71 was increasingly redundant.
Advocates countered that no other platform could match the combination of speed, altitude, and real-time adaptability that the Blackbird provided. By the late 1980s, the aircraft had become both a symbol and a tool, a testament to human ingenuity and the embodiment of strategic necessity. Engineers continued to draw lessons from the aircraft's design, influencing future generations of aerospace technology, including stealth aircraft, high-speed reconnaissance drones, and advanced materials science. The Blackbird also became an institutional legend. Stories of near disasters, miraculous recoveries, and unprecedented intelligence collection circulated among pilots and crews, fostering a culture of excellence and resilience. These stories, though often classified, contributed to the aircraft's mythos and reinforced the dedication of those involved in its operations. Amid increasing political and technological pressures, a series of evaluations were conducted to determine the aircraft's continued relevance. These evaluations assessed cost-effectiveness, operational capability, and strategic necessity. The results consistently demonstrated that despite emerging alternatives, the SR-71 remained unparalleled in its ability to provide rapid, actionable intelligence in contested environments. As the decade drew to a close, the Blackbird program faced a paradoxical reality. While the aircraft had demonstrated unmatched capability and provided invaluable intelligence, the combination of high operational costs, political scrutiny, and emerging technologies increasingly threatened its survival. Yet each mission completed, each sensor reading collected, and each successful flight continued to reinforce the argument that the SR-71 was indispensable. Crews reflected on the enduring lessons of flying the Blackbird. Speed, altitude, precision, teamwork, and discipline were paramount. The aircraft demanded absolute attention to detail, constant vigilance, and unwavering trust in both human and mechanical systems. Pilots often described their experiences as transformative, citing the combination of danger, technical mastery, and historical significance as unparalleled in aviation history. Even as the SR-71 approached the end of its operational life, it continued to perform missions critical to national security. Its contributions during the final years of the Cold War included confirming treaty compliance, monitoring adversary activity, and providing intelligence that informed military strategy and diplomatic efforts. Each flight served as a reminder of the aircraft's unique role in shaping global events, often unseen and unacknowledged by the public. Ultimately, the late 1980s represented a delicate balance between operational necessity and political reality. The SR-71 had reached the pinnacle of its technological evolution, yet its continued existence depended on decisions made far from the cockpit. Advocates fought to preserve the program, highlighting its strategic value, operational flexibility, and unmatched capabilities. Critics pointed to cost, fuel consumption, and the emerging technologies that could eventually replace the aircraft at lower cost and risk. The tension between these perspectives defined the Blackbird's final decade, creating an environment where each mission was both a tactical achievement and a testament to the program's resilience. The aircraft had survived decades of operational challenges, near disasters, and political scrutiny, yet its ultimate fate remained uncertain. As the late 1980s unfolded, the SR-71 Blackbird continued to operate at the very limits of human and technological capability. With tensions between the United States and the Soviet Union still simmering, intelligence gathering remained a top priority. Missions during this period were often conducted under extreme secrecy, sometimes so classified that even the pilots were given only partial information about objectives. One particularly tense episode occurred over the Arctic Ocean, where an SR-71 crew detected unexpected radar signals emanating from Soviet air defense systems. The signals suggested that an advanced interceptor or missile platform had been deployed, potentially capable of reaching the Blackbird at operational altitude. The crew maintained composure, executing a precise evasive maneuver that relied on a combination of high-speed acceleration and altitude adjustments. Within minutes, the aircraft was beyond the effective range of the detected systems, and the mission continued successfully. These near shoot-downs were not uncommon. Pilots recalled dozens of instances where radar walks, missile launches, or sudden atmospheric anomalies created moments of intense risk. Each scenario tested both training and trust. RSOs and pilots had to react instantly, following protocols honed over years of preparation. Small errors could be fatal, but disciplined execution allowed the Blackbird to continue its unparalleled reconnaissance work. During this period, program leadership was also grappling with the realities of budget constraints and modernization. The Air Force and Pentagon faced difficult choices: maintain the SR-71 at its full operational tempo, reduce the fleet, or begin planning for retirement in favor of emerging technologies. Each option had profound strategic implications. Advocates argued that no satellite or stealth platform could replicate the combination of speed, altitude, and real-time intelligence that the Blackbird provided. Critics focused on cost, fuel consumption, and the challenges of sustaining such a specialized program. Declassified reports from this era revealed the detailed planning behind each mission. Flight paths were meticulously calculated, often involving multiple aerial refueling operations over remote regions. Meteorological data was studied intensively to anticipate wind shear, turbulence, and temperature gradients that could affect high-speed flight. Ground support crews performed exhaustive checks, aware that even minor oversights could escalate into catastrophic failure. Several pilots from this era later described the intense psychological pressure of flying the Blackbird. Long-duration missions often required maintaining near-constant attention for hours at Mach 3+, with minimal margin for error. The cockpit environment was physically constraining, and high-altitude conditions placed additional demands on the human body. Yet, pilots consistently reported a profound sense of accomplishment and awe at operating the world's most advanced aircraft. Strategically, the SR-71's intelligence output during this period proved critical. In Europe, its missions provided verification of Warsaw Pact troop movements, deployment of intermediate-range missiles, and the construction of radar and anti-aircraft
sites. In Asia, flights monitored volatile regions, offering early warning of potential escalations. The aircraft's ability to provide rapid, actionable intelligence influenced both tactical decisions and high-level diplomatic negotiations, helping to avoid misunderstandings that could have escalated into conflict. One mission over the Middle East highlighted the Blackbird's unique capabilities. Intelligence suggested that a neighboring country was preparing to move advanced surface-to-air missile systems. Satellite imagery was inconclusive due to persistent cloud cover, but the SR-71's sensors penetrated these barriers, detecting heat signatures and radar emissions that confirmed the deployment. The intelligence allowed U.S. advisors to counsel allied governments and prepare contingency measures, preventing a potential crisis. Despite its operational successes, internal threats to the program continued. Congress and the Pentagon repeatedly questioned the cost-effectiveness of the SR-71. Each flight was expensive, requiring specialized fuel, KC-135 tankers, and maintenance teams that were unmatched in expertise. Critics pointed to emerging reconnaissance technologies, including high-resolution satellites and unmanned aerial vehicles, suggesting that these systems could eventually replace the Blackbird at lower cost and risk. Program advocates countered with clear operational evidence. They emphasized that the Blackbird could gather real-time dynamic intelligence in ways satellites could not.
Unlike orbiting systems, the SR-71 could change flight paths, respond to emerging threats, and observe in multiple spectrums simultaneously. Its speed made it effectively invulnerable to known interceptors and missile systems. These arguments, combined with pilot testimonies and historical mission records, often persuaded decision-makers to preserve limited flight operations. Technical challenges persisted. Engine unstarts, fuel system anomalies, and occasional sensor malfunctions were ongoing concerns. Each incident required careful analysis, system modification, or procedural adjustment. Engineers worked continuously to refine components, improve reliability, and ensure that the Blackbird remained safe and effective. The aircraft's titanium structure, designed to withstand extreme heat at Mach 3+, required unique maintenance procedures. Even minor structural imperfections could lead to serious operational issues. Pilots' accounts provide a vivid window into these challenges. They described flying through turbulence that felt like invisible walls, adjusting throttle and control surfaces in milliseconds to maintain stability. They spoke of navigating by instinct, relying on a deep understanding of the aircraft's performance envelope. RSOs monitored dozens of instruments simultaneously, detecting minute deviations and advising corrective actions. Success depended entirely on seamless coordination between human and machine. By the late 1980s, the SR-71 had become more than a reconnaissance aircraft. It was a symbol of technological achievement and strategic resolve. Its ability to operate in contested airspace with near impunity inspired confidence among policymakers and awe among aerospace engineers. Stories of near misses, flawless intelligence collection, and extreme operational demands contributed to a mythology surrounding the aircraft, further solidifying its status as an icon of the Cold War. As the decade drew to a close, decisions regarding the Blackbird's future became increasingly urgent. Emerging technologies promised new capabilities, but none could replicate the combination of speed, altitude, and adaptability that had defined the SR-71's operational legacy. Advocates continued to argue for its preservation, citing historical successes, ongoing intelligence needs, and the aircraft's unique contributions to national security. Ultimately, these final years of the Cold War showcased the Blackbird at its peak operational effectiveness, while simultaneously highlighting the fragility of human-made systems in a complex political environment. The aircraft flew faster than any missile, higher than most interceptors, and provided intelligence that shaped global strategy, yet its continued existence was never guaranteed. Each mission was a testament to both human skill and technological mastery, demonstrating that the line between survival and disaster was razor-thin at every altitude and speed. By the early 1990s, the geopolitical landscape was shifting dramatically. The Cold War, which had defined the SR-71 Blackbird's purpose for nearly 3 decades, was drawing to a close. The Soviet Union was disintegrating, and the global threat environment was evolving. Yet, even in this new era, the Blackbird remained a vital intelligence asset, capable of missions that no other platform could achieve with equal speed and reliability. The final Cold War missions of the SR-71 were among the most technically demanding. Intelligence priorities had shifted toward confirming compliance with arms reduction treaties, monitoring the rapid demobilization of Soviet forces, and observing potential flashpoints in regions previously inaccessible to Western surveillance. Despite the diminishing threat from manned interceptors, the Blackbird faced persistent operational hazards, including unpredictable weather, instrument anomalies, and mechanical stresses induced by sustained Mach 3+ flight. Pilots and RSOs continued to demonstrate extraordinary skill, often performing missions with minimal margin for error. During a notable sortie over Eastern Europe, the crew encountered an unplanned atmospheric disturbance that caused transient instability at cruising altitude. The aircraft's sophisticated flight control systems, combined with pilot precision, allowed for immediate correction. Post-mission analysis highlighted how these adaptive maneuvers provided data that would inform both future Blackbird operations and the development of successor high-speed reconnaissance aircraft. Operational tempo remained high even as the world's focus shifted toward diplomacy and economic restructuring. The SR-71 collected intelligence that verified troop withdrawals, documented the dismantling of military infrastructure, and monitored nuclear sites. In many cases, this intelligence was critical in ensuring that treaty compliance was genuine and that potential deviations were identified promptly. Meanwhile, the program faced increasing scrutiny. The end of the Cold War prompted questions about the continued necessity of maintaining such an expensive and highly specialized fleet. Critics highlighted the substantial costs associated with JP-7 fuel, KC-135 refueling support, and the highly skilled maintenance workforce. They argued that satellites, combined with emerging unmanned aerial reconnaissance technologies, could provide sufficient intelligence at a fraction of the cost. Program defenders countered with irrefutable evidence. The SR-71's unmatched speed and altitude allowed it to collect real-time, high-resolution data in regions where satellites were limited by orbit, weather, or political restrictions. No other platform could respond as rapidly to emergent intelligence needs, nor could any system match the Blackbird's proven track record of evading detection and interception. The aircraft's legendary speed was both an operational necessity and a psychological tool. Pilots described the sensation of traveling faster than any potential threat as both empowering and humbling. RSOs monitored a vast array of sensors simultaneously, from photographic cameras to infrared scanners to electronic intelligence collectors. Their reports contributed directly to strategic decision-making at the highest levels of government. During one particularly tense mission, a Blackbird flight was tasked with verifying the deactivation of a Soviet missile site. The operation required precise navigation over mountainous terrain with unpredictable wind shear. The crew executed multiple mid-flight course adjustments, coordinating with refueling tankers positioned along the route. Despite minor mechanical anomalies, the mission was completed successfully, and the intelligence gathered was subsequently used to confirm treaty compliance during international negotiations. As the decade progressed, maintenance challenges became more acute. The SR-71's titanium airframe, while resilient at high speeds, required meticulous inspection to detect microfractures and structural fatigue. Each engine underwent extensive monitoring for wear and thermal stress. The aircraft's fuel system, optimized for Mach 3 operations, demanded exacting attention. Maintenance personnel worked tirelessly to ensure that each sortie could be conducted safely, preserving both human life and technological capability. The human dimension remained critical. Pilots often spoke of the profound psychological demands of Blackbird operations. Long missions at extreme altitudes, the high-speed environment, and the constant need for precision fostered a unique camaraderie among crew members. RSOs and pilots developed
An almost instinctual coordination, relying on subtle cues and shared experience to navigate complex operational scenarios. By the mid-1990s, discussions regarding the aircraft's retirement intensified. With the Soviet threat diminished, satellite reconnaissance increasingly capable, and new unmanned systems under development, the strategic justification for the Blackbird was evolving. Some argued that the fleet should be mothballed to preserve historical aircraft and reallocate resources. Others contended that retaining operational capability remained vital for unforeseen contingencies.
During this period, the SR-71 continued to demonstrate its value. Missions conducted over the Middle East, Eastern Europe, and Asia provided intelligence that influenced both military planning and diplomatic initiatives. Even in an era of reduced global tension, the Blackbird proved uniquely capable of rapid deployment, high-resolution observation, and real-time intelligence transmission. Program advocates emphasized that the SR-71 was not simply an aircraft, it was a system of human expertise, technological innovation, and operational excellence. Pilots, RSOs, engineers, and ground crews together formed an ecosystem that enabled the aircraft to operate safely at the edge of technological possibility. Their combined efforts allowed the United States to maintain strategic awareness during a period of unprecedented geopolitical change. Despite the mounting pressures to retire the fleet, each mission completed reinforced the Blackbird's irreplaceable nature. Flights over sensitive regions confirmed arms reduction compliance, monitored troop withdrawals, and provided early warning of potential destabilizing activities. In every instance, the aircraft's capabilities exceeded those of any satellite, drone, or conventional reconnaissance platform available at the time. The twilight years of the SR-71 were therefore defined by a dual reality: unparalleled operational success and an uncertain future. Each flight underscored the aircraft's unmatched speed, altitude, and intelligence-gathering capacity, while budgetary and strategic considerations cast a shadow over its continued deployment. By the late 1990s, a decision became inevitable. After more than 30 decades of extraordinary service, the SR-71 would face retirement. The debate was intense, with strong arguments on both sides. Proponents of continued operation cited the aircraft's proven track record and unique capabilities. Opponents emphasized the costs, maintenance challenges, and the rise of alternative reconnaissance technologies. Ultimately, the decision reflected a combination of strategic, fiscal, and technological realities. While the SR-71 had flown missions that shaped global events, preserved lives, and provided irreplaceable intelligence, the post-Cold War environment demanded a shift toward more sustainable and flexible systems. Yet even as the Blackbird's operational chapter drew to a close, its legacy remained secure. The aircraft had demonstrated the limits of human engineering, the potential of high-speed reconnaissance, and the importance of adaptability, precision, and courage. Its influence would extend to future generations of aircraft, satellites, and intelligence systems, ensuring that the lessons of the SR-71 would endure long after its final flight.
With the SR-71 Blackbird approaching retirement in the late 1990s, its operational missions gradually shifted from active intelligence collection to limited specialized tasks. Even in its twilight, the aircraft demonstrated capabilities unmatched by contemporary platforms, providing validation for emerging reconnaissance systems and serving as a testbed for high-speed avionics, sensor suites, and materials science. Post-retirement operations were carefully managed. While the aircraft no longer flew routine strategic missions, select flights continued to gather data for research and development purposes. These included high-altitude performance tests, sensor calibration exercises, and the evaluation of next-generation reconnaissance systems. Engineers and pilots collaborated to extract every possible insight from the Blackbird's design and operational experience. In parallel, the SR-71's influence extended into the broader aerospace community. Aerospace engineers studied its titanium airframe, heat-resistant coatings, and aerodynamic refinements. The lessons learned informed the development of stealth aircraft, high-speed reconnaissance drones, hypersonic prototypes, and advanced materials capable of withstanding extreme thermal and mechanical stress. Many contemporary aircraft designs owe their lineage directly to innovations pioneered during the Blackbird program.
The human element remained central. Pilots and RSOs who had served aboard the SR-71 became mentors, training the next generation of aviators and intelligence specialists. Their experience in managing extreme environments, high-stress decision-making, and multi-sensor operations provided insights that could not be gleaned from textbooks or simulations. Many of these veterans transitioned into program management, contributing to the design of unmanned aerial vehicles, high-speed reconnaissance aircraft, and integrated intelligence systems. Museum preservation efforts began in earnest during this period. Recognizing the aircraft's historical and technological significance, several SR-71s were meticulously restored and placed on display at prominent institutions, including the Smithsonian National Air and Space Museum and the United States Air Force Museum at Wright-Patterson. These exhibits allowed the public to witness firsthand the scale, complexity, and ingenuity of a machine that had flown faster than any missile and higher than most interceptors. Restoration teams faced unique challenges. The Blackbird's titanium airframe required specialized welding techniques, and many components had been custom-built with no commercial equivalents. Instruments, sensors, and flight systems had to be preserved or reconstructed to ensure authenticity. Maintenance manuals, flight logs, and historical records were invaluable in guiding these restoration efforts. The Blackbird's post-retirement influence extended into education as well. Universities and aerospace institutions integrated SR-71 case studies into engineering curricula, emphasizing lessons in high-speed aerodynamics, thermal management, materials science, and human-machine interface. Students examined flight profiles, engine performance, and mission planning, gaining insights that bridged the gap between theory and applied technology. Public fascination with the Blackbird also grew. Documentaries, books, and magazine features recounted its history, operational challenges, and strategic contributions. Pilots, RSOs, and engineers shared their experiences, providing an inside perspective on one of the most extraordinary aviation programs of the 20th century. The SR-71 became a symbol not only of American technological prowess, but also of human ingenuity and resilience under extreme conditions. Post-retirement, the Blackbird continued to influence aerospace innovation. High-speed data links, real-time sensor integration, and adaptive flight control systems were all areas where lessons from the SR-71 directly informed development. Programs focused on hypersonic flight, spaceplane concepts, and advanced reconnaissance drones benefited from decades of operational knowledge accumulated by the Blackbird's crews and engineers. Internationally, the SR-71 set benchmarks that shaped global aerospace programs. Other nations studied its design and operational concepts to inform their own high-speed research, sensor development, and materials engineering projects. While direct replication was impossible due to proprietary technologies and classified systems, the Blackbird's legacy inspired innovation worldwide. Veterans of the SR-71 program frequently emphasized the importance of teamwork and human factors. The extreme environment of Mach 3+ flight highlighted the interdependence of pilot, RSO, engineers, and ground crews. Lessons in communication, situational awareness, and adaptive problem-solving have been applied across aerospace operations, from space missions to unmanned drone operations. In addition to technological and educational influence, the Blackbird inspired cultural fascination. Its silhouette became iconic, its missions legendary, and its capabilities almost mythic. Popular media, science fiction, and aviation literature referenced the aircraft, often portraying it as the pinnacle of human achievement in the realm of flight. The SR-71's retirement did not mark the end of its operational impact. Information gathered during its decades of service remained invaluable. Declassified mission data has been used to study long-term geopolitical patterns, analyze air defense evolution, and understand the limits of high-speed flight. Researchers in multiple disciplines continue to examine these records, extracting lessons that extend well beyond the original military context. Even decades after its last operational flight, the Blackbird served as a benchmark against which new aerospace achievements were measured. Its speed, altitude, and intelligence gathering capabilities established a standard of excellence. Pilots who trained on or with the Blackbird often remarked that no simulator or training aircraft could replicate the demands and rewards of flying this extraordinary machine. The aircraft's legacy also reinforced the importance of visionary thinking. The SR-71 program had begun in an era where supersonic flight at extreme altitudes was considered near impossible. Through innovation, engineering ingenuity, and operational excellence, it achieved feats that reshaped strategic intelligence and aerospace engineering. This lesson, that audacious goals can lead to unprecedented achievement, remains a guiding principle in both military and civilian aerospace development. Finally, the Blackbird's enduring symbol of technological audacity, human courage, and strategic foresight inspired new generations of engineers, pilots, and intelligence professionals. Its story continues to be told, studied, and admired, serving as a reminder of what can be accomplished when imagination, skill, and determination converge. Entering the 21st century, the SR-71 Blackbird had long retired from active service, yet its influence on aerospace technology remained profound. While satellites, drones, and stealth aircraft now performed routine reconnaissance missions, the principles embodied by the Blackbird continued to guide engineers and strategists alike. Its lessons extended far beyond Cold War operations, informing modern hypersonic flight, materials science, and sensor integration. The SR-71's design innovations, particularly its titanium airframe and thermal management systems, became foundational for hypersonic research. Engineers studying hypersonic vehicles often referenced the Blackbird as a practical case study in balancing speed, structural integrity, and environmental stressors. For instance, the expansion of the airframe at Mach 3+ speeds and the resulting thermal effects offered invaluable data for the development of heat-resistant composites in next-generation aircraft. Aerodynamic lessons from the SR-71 also proved influential. The aircraft's slender fuselage, chines, and swept wing design optimized stability at high speeds and altitudes, while minimizing radar cross-section to some degree. These design principles informed the development of stealth aircraft like the F-117, B-2, and future unmanned systems designed for rapid penetration of contested airspace. Hypersonic flight envelopes, coupled with low observability, became central goals of 21st century aerospace engineering. Sensor technology benefited as well. The Blackbird's E-lint and photographic systems demonstrated the advantages of real-time multispectral intelligence collection from high altitudes. Modern platforms, including unmanned aerial vehicles and reconnaissance satellites, adopted integrated sensor packages capable of simultaneous infrared, optical, and electronic data capture, a direct conceptual descendant of the Blackbird's approach. Beyond technology, the SR-71 influenced operational philosophy. Commanders recognized the value of rapid intelligence collection and
dissemination. High-speed reconnaissance allowed decision-makers to act on emerging threats quickly, a principle now embedded in modern command and control doctrines. Lessons learned from Blackbird operations regarding mission planning, risk assessment, and crew coordination have been incorporated into contemporary training programs for both manned and unmanned systems. The aircraft's cultural impact also persisted. Aviation enthusiasts, historians, and the general public remained fascinated by the Blackbird's combination of speed, altitude, and secrecy.
Documentaries, museum exhibits, and books continued to recount its exploits, often emphasizing not only the technical marvel of the aircraft, but also the bravery and skill of the pilots and RSOs who flew it. In educational contexts, the SR-71 became a cornerstone for aerospace curricula. Universities incorporated case studies on its design, operational history, and mission planning into engineering programs. Students analyzed flight profiles, material science challenges, and sensor integration techniques, gaining insights that connected theoretical knowledge with practical application. Many aerospace professionals credited their inspiration to the Blackbird, citing its audacity as a benchmark for innovation. The SR-71 also left a strategic legacy. Its ability to penetrate denied airspace without detection provided a template for operational concepts involving speed, altitude, and evasive maneuvering. Modern hypersonic reconnaissance and strike platforms, while technologically distinct, owe conceptual debts to the operational lessons of the Blackbird. The aircraft's missions demonstrated the utility of combining extreme performance with precise intelligence collection, a concept that continues to shape U.S. military doctrine. Even the aircraft's limitations offered valuable lessons. The reliance on specialized JP-7 fuel, KC-135 tankers, and intensive maintenance underscored the challenges of sustaining cutting-edge systems over decades. These logistical and operational considerations informed the planning of future high-performance aircraft and space vehicles, highlighting the balance between capability, cost, and sustainability. Internationally, the Blackbird set benchmarks for aerospace programs. While the United States maintained operational secrecy, Allied nations studied the aircraft's design and operational concepts to guide their own high-speed and high-altitude research. Although direct replication was impossible due to proprietary technologies, the principles of thermal management, aerodynamics, and sensor integration influenced global aerospace development. The Blackbird also inspired new generations of engineers and pilots. The mystique surrounding its speed, altitude, and operational secrecy instilled a sense of possibility, encouraging innovation and bold problem-solving. Stories of near-miss incidents, flawless intelligence collection, and extreme operational challenges highlighted the human dimension of technological achievement. These narratives emphasized that success depended not only on engineering, but also on teamwork, discipline, and human ingenuity. Additionally, the SR-71's post-retirement role as an educational and inspirational tool extended into simulation and modeling. Advanced flight simulators recreated its flight characteristics, providing researchers and students with realistic data on high-speed aerodynamics, control systems, and thermal effects. This virtual experience allowed the Blackbird's operational lessons to reach a wider audience, further cementing its legacy. Museums and public exhibits continued to serve as tangible reminders of the aircraft's historical significance. Restored SR-71s allowed visitors to appreciate the scale and complexity of a machine capable of Mach 3+ speeds. Maintenance teams collaborated with historians to ensure authenticity, providing insights into the aircraft's unique construction, systems, and operational procedures. The public's fascination reinforced the Blackbird's status as both a technological and cultural icon. In the context of modern aerospace, the Blackbird's legacy is multifaceted. Technologically, it provided a foundation for high-speed and high-altitude research. Operationally, it demonstrated the value of rapid intelligence collection and strategic flexibility. Culturally, it inspired fascination and respect for human ingenuity. Each of these dimensions continues to influence contemporary aerospace development. The story of the SR-71 is also a reminder of the balance between ambition and practicality. Pioneering technologies often require extraordinary resources, specialized personnel, and risk acceptance. The Blackbird's success illustrates how visionary engineering, combined with disciplined execution, can overcome seemingly insurmountable challenges. These lessons are as relevant today as they were during the aircraft's operational heyday. Looking ahead, the Blackbird continues to inspire efforts in hypersonics, spaceplane design, and advanced reconnaissance systems. Its influence extends to unmanned platforms capable of sustained high-speed operations, demonstrating that lessons from past achievements remain vital in guiding future innovation. Aerospace programs frequently cite the Blackbird as a benchmark for what is possible when engineering ambition meets operational necessity. In summary, the SR-71 Blackbird's post-retirement legacy is as profound as its operational history. Its influence spans technology, strategy, education, and culture. While no longer in active service, its principles, lessons, and inspiration continue to shape aerospace engineering, military doctrine, and public imagination. The aircraft remains an enduring symbol of human achievement at the intersection of speed, altitude, and intelligence. As the SR-71 Blackbird moved definitively into retirement, the focus shifted towards preserving not only the aircraft, but also the stories of those who made its missions possible. Pilots, RSOs, engineers, and maintenance crews shared recollections that revealed the profound combination of human skill, courage, and technological ingenuity that had defined decades of operations. Veterans consistently emphasized that the Blackbird demanded a unique mindset. Speed, altitude, and operational secrecy were not merely technical requirements, they were psychological imperatives. Pilots described the surreal experience of Mach 3+ flight, where time seemed compressed, the curvature of the Earth became visible, and the usual rules of conventional flight appeared almost suspended. RSOs highlighted the constant need to monitor, interpret, and respond to vast streams of data in real time, where any lapse could jeopardize both mission success and crew safety. Engineers reflected on the aircraft's design as a pinnacle of applied science. Titanium construction, advanced avionics, thermal management, and high-speed aerodynamics were all pushed to their limits. Lessons learned from the SR-71 program informed everything from stealth technology to hypersonic research to the development of modern unmanned reconnaissance platforms. They emphasized that the aircraft's success was as much about meticulous maintenance, human oversight, and teamwork as it was about technological prowess. The aircraft's retirement did not diminish its influence. Declassified mission data became a treasure trove for analysts, providing insights into Cold War strategy, adversary capabilities, and aerospace engineering challenges. Studies of flight records, sensor outputs, and near-miss incidents illuminated both the operational complexity of high-speed flight and the strategic decisions enabled by real-time intelligence. Museums around the world celebrated the SR-71's achievements. Carefully restored aircraft provided tangible proof of its size, complexity, and innovation. Visitors could appreciate the precision of its engineering, the ergonomics of its cockpit, and the remarkable speed and altitude it achieved. Educational programs incorporated Blackbird case studies into curricula spanning engineering, physics, and military strategy, ensuring that its lessons would continue to shape new generations. The Blackbird also became a symbol in popular culture. Its missions, speed, and secrecy captured public imagination, inspiring books, documentaries, and media coverage. Pilots' daring feats, near-miss incidents, and flawless intelligence collection contributed to a mythology that highlighted both human courage and technological achievement. Strategically, the SR-71 remained a benchmark for what reconnaissance aircraft could accomplish. Modern intelligence-gathering platforms, both manned and unmanned, are evaluated against the standards set by the Blackbird. Its combination of speed, altitude, and multi-sensor capability demonstrated principles that continue to inform strategic planning, rapid response intelligence, and operational risk assessment. Reflecting on the aircraft's history, many veterans emphasized a single theme. The Blackbird exemplified human ingenuity in extreme conditions. It pushed the boundaries of engineering, demanded exceptional human skill, and operated successfully in some of the most challenging environments ever
Faced by a reconnaissance platform. Its story is one of vision, perseverance, and the relentless pursuit of excellence. The SR-71's legacy extends beyond the Cold War. Hypersonic research, stealth technology, high-altitude reconnaissance, and sensor integration all bear the imprint of lessons learned from Blackbird operations. Programs in both military and civilian aerospace continue to reference its design, operational principles, and human factors considerations as a model for innovation. Pilots often spoke of the almost philosophical nature of flying the Blackbird. The aircraft required complete focus, situational awareness, and trust in both machine and co-pilot. Each mission was a delicate balance of speed, altitude, and timing. The experience instilled in crews a profound appreciation for precision, preparation, and teamwork. Lessons that transcended aviation and informed leadership, decision-making, and operational planning in broader contexts. RSOs emphasized the complexity of managing data in real time. Every mission generated massive quantities of information, from photographic intelligence to radar emissions. Processing this data required not only advanced systems, but also human judgment to interpret patterns, identify anomalies, and provide actionable insights. This interplay between technology and human intellect exemplified the core operational philosophy of the Blackbird program. Engineers highlighted innovations that remain relevant. Titanium metallurgy, thermal protection, and aerodynamic design solutions developed for the SR-71 influenced subsequent aircraft, spacecraft, and unmanned systems. Lessons learned from maintenance protocols, refueling operations, and high-speed operational planning have been integrated into modern aerospace programs worldwide. Even decades after its last operational flight, the SR-71 serves as a teaching tool, benchmark, and inspiration. Its story demonstrates that ambition, vision, and human skill can combine to produce results that redefine the limits of possibility. The aircraft stands as a testament to the enduring value of innovation, collaboration, and courage. In conclusion, the SR-71 Blackbird is more than a historical aircraft. It embodies a legacy of technological achievement, operational excellence, and human ingenuity. Its missions shaped global strategy, advanced aerospace engineering, and inspired generations of pilots, engineers, and enthusiasts. While it no longer flies, its impact continues to resonate, ensuring that the story of the Blackbird remains a cornerstone of aerospace history and a symbol of what can be achieved when vision and determination converge at the edge of possibility. As the SR-71 Blackbird neared the end of its operational career, each remaining mission became a combination of final achievement and historical significance. Pilots and RSOs were acutely aware that they were operating one of the most iconic aircraft ever built, performing tasks that would soon become historical records rather than active intelligence missions. These final missions focused primarily on testing, evaluation, and selective intelligence collection. While the Cold War had ended, global conflicts and emerging threats required verification of military installations, monitoring of sensitive regions, and support for allied nations. The Blackbird's speed and altitude remained unmatched, allowing for rapid, secure reconnaissance even in politically sensitive airspace. Pilots recalled the intensity of these flights. Even in the final years, the aircraft demanded absolute attention. Flying at Mach 3+, the Blackbird required careful monitoring of engine performance, fuel systems, and structural integrity. RSOs simultaneously managed complex sensor arrays, ensuring that every second of flight produced valuable data.
The precision and coordination needed underscored decades of training and operational experience. Maintenance crews played a crucial role in these last missions. Each sortie required meticulous preparation, including inspection of titanium airframe panels, engine tuning, and recalibration of sensor systems. The aircraft's unique requirements demanded expertise that had been developed over decades. The dedication of these teams ensured that the Blackbird could operate safely and effectively even in its final operational chapter. Among the most notable final missions were flights over areas of geopolitical tension in the Middle East and Eastern Europe. These sorties gathered intelligence on new military systems, confirmed compliance with treaties, and observed infrastructure developments. Each mission contributed not only to immediate intelligence objectives, but also to long-term historical records that would later inform policymakers and researchers. Human stories from these final missions highlight the profound impact of the Blackbird. Pilots described feelings of awe and responsibility, knowing they were flying a machine that had become both a legend and a critical tool of national security. RSOs emphasized the intellectual challenge of interpreting real-time data under extreme conditions. Engineers and maintenance personnel spoke of pride in ensuring the aircraft could perform flawlessly, even in its last operational flights. Near-miss incidents, although less frequent than during peak Cold War operations, still occurred. Pilots recounted encounters with unexpected turbulence, mechanical anomalies, or minor sensor malfunctions. Each event required rapid decision-making and demonstrated the continued importance of training, expertise, and teamwork. These experiences underscored that even at the end of its service life, the SR-71 demanded respect and skill. The cumulative impact of the Blackbird's career became increasingly evident. Over 30 years, it had flown hundreds of missions, penetrated denied airspace, and gathered intelligence that shaped global strategy. From monitoring Soviet missile deployments to verifying arms reduction treaties, the aircraft's contributions were unparalleled. Its operational history served as both a technical achievement and a strategic asset. Pilots and RSOs often reflected on the psychological aspects of flying the Blackbird. The combination of extreme speed, altitude, and mission secrecy required mental acuity, discipline, and composure under pressure. Long-duration flights at Mach 3+ compressed time and perception, creating experiences described as both exhilarating and humbling. These human dimensions of high-speed reconnaissance became a defining feature of the Blackbird's legacy. The final missions also emphasized the technological marvel of the aircraft. Titanium construction, advanced sensors, high-performance engines, and thermal management systems allowed the Blackbird to operate in environments and conditions no other aircraft could. Engineers noted that even post-retirement, lessons from these systems continued to inform contemporary aerospace development, including hypersonic flight and next-generation reconnaissance platforms. As retirement approached, the SR-71's legacy was reflected in both tangible and intangible ways. Restored aircraft displayed in museums offered a visible testament to engineering excellence, while declassified mission records provided a wealth of knowledge for historians, engineers, and military planners. The human stories of bravery, skill, and teamwork remained central to the narrative, illustrating that technology alone was never enough. Success depended equally on the people who operated and maintained the aircraft. The final operational flights were ceremonial as well as functional. They honored the crews, engineers, and planners who had sustained the program over decades. Pilots and RSOs flew with a deep sense of pride, aware that these missions represented the culmination of years of service, innovation, and achievement. These flights were a bridge between history and legacy, connecting operational accomplishment with educational, cultural, and technological impact. In the final analysis, the SR-71's operational history and post-retirement influence converged. The aircraft had proven the value of extreme speed, high-altitude performance, and integrated intelligence collection. Its human dimension, pilots, RSOs, and engineers highlighted the necessity of skill, teamwork, and dedication. and its technological legacy informed generations of aerospace innovation, from stealth design to hypersonics, from sensors to material science. These final missions and reflections served as a reminder that the SR-71 was not simply a plane, but a symbol of what human ingenuity could achieve under extreme conditions. Its story encompassed audacious vision, disciplined execution, and transformative impact, creating a benchmark for excellence in aviation and strategic intelligence. The SR-71 Blackbird, after decades of service, had moved beyond its operational life, yet its story remained as vivid and influential as ever. From its inception in the early Cold War to its retirement and post-retirement legacy, the Blackbird represented the pinnacle of human ingenuity, technological mastery, and strategic vision. The aircraft's unique combination of speed, altitude, and reconnaissance capability allowed the United States to gather intelligence that was previously unimaginable. Pilots and RSOs recalled missions where they had flown faster than any missile, evading detection and interception while observing strategic targets with unprecedented clarity. Each mission was a testament to the seamless integration of human skill, engineering excellence, and tactical precision. In reflecting on the SR-71's legacy, one cannot
overlook the human element. The bravery of pilots who navigated extreme environments at Mach 3+, the focus and precision of RSOs managing intricate sensor arrays, and the relentless dedication of engineers and maintenance crews together defined what it meant to operate the Blackbird. Their stories, challenges, and triumphs are as much a part of the Blackbird's legacy as its technological achievements. Even decades after its last flight, the Blackbird continues to inspire. Museums around the world display restored aircraft, offering tangible evidence of its size, complexity, and innovative design. Students, engineers, and aviation enthusiasts study its aerodynamics, titanium construction, and thermal management systems, drawing lessons for the next generation of aerospace innovation. The SR-71 also transformed the way intelligence was collected and applied. Its operational philosophy emphasized speed, precision, and adaptability, principles that now underpin modern reconnaissance, surveillance, and rapid response strategies. Lessons in mission planning, data collection, and real-time decision-making have informed both manned and unmanned platforms, bridging the gap between Cold War-era ingenuity and 21st-century technology. Technologically, the Blackbird's impact is seen in modern stealth aircraft, hypersonic vehicles, and advanced reconnaissance systems. Its innovations in material science, aerodynamics, and sensor integration set benchmarks that continued to influence aircraft design. Engineers studying the aircraft find in it a model of problem-solving, pushing boundaries, and achieving the extraordinary. Culturally, the SR-71 Blackbird became an icon. Its sleek, futuristic design captured the imagination of generations. Media coverage, documentaries, and books celebrated its achievements, recounting both the daring missions and the dedication of the people behind them. The aircraft's mythology, a combination of speed, secrecy, and audacity, ensured that it would remain a symbol of American ingenuity and determination. The operational history of the Blackbird also offers lessons in perseverance and adaptability. Missions often required pilots and crews to overcome extreme technical challenges, unexpected hazards, and strategic complexities. They demonstrated the importance of preparation, teamwork, and decisive action under pressure. These principles remain relevant today, whether applied in aerospace, defense, or any field requiring innovation under constraints. The Blackbird's retirement did not diminish its relevance. Post-retirement flights, restoration projects, educational programs, and research applications ensured that its lessons continued to shape aerospace development.
hypersonic research, unmanned high-speed platforms, and advanced surveillance systems all draw upon the legacy of the SR-71, highlighting the enduring value of its design and operational philosophy. In conclusion, the SR-71 Blackbird stands as a testament to human ambition realized. It is a symbol of what can be achieved when vision, technology, and courage converge. Its missions shaped the course of history. Its design influenced generations of aerospace innovation, and its story continues to inspire those who dare to push the boundaries of possibility. The Blackbird reminds us that innovation is not merely about speed or altitude. It is about vision, precision, collaboration, and the relentless pursuit of excellence. From the skies over Cold War hotspots to the laboratories and museums of the 21st century, the SR-71's influence is enduring, its lessons timeless, and its story one of humanity's greatest achievements in aviation history. Today, the Blackbird's legacy is preserved not just in metal and titanium, but in the minds and memories of those who flew it, maintained it, and studied it. Its tale exemplifies the pinnacle of aerospace achievement, the courage of human endeavor, and the transformative power of technology when combined with determination and ingenuity. As future generations look to the skies and dream of flight at unprecedented speeds, they will find inspiration in the story of the SR-71 Blackbird, the jet the Soviets could never shoot down, the aircraft that defied limits, and the enduring symbol of human achievement in the realm of flight. The SR-71 Blackbird wasn't just a jet, it was a message. A machine so fast, so advanced, that no enemy could ever stop it. If you love true Cold War stories, secret intelligence missions, legendary aircraft, and the hidden side of American history, you're in the right place. Follow and subscribe to Untold Golden History for powerful, real stories that history books only whispered about. Stories of courage, technology, and moments that changed the world forever. The greatest stories in history were never meant to stay hidden.